So in the last video we made a 5 GHz double biquad antenna. Now I was so pleased with how that turned out with the actual housing and everything, I've decided to make a 2.4 GHz double biquad antenna using the same technique to construct the housing. Now this one is a 2.4 GHz double biquad antenna, and it is actually a prototype that I made a couple of years ago. And this was another housing that I played around with at the time, and I was really pleased with this at the time. This one I never got around to painting or anything else. I just keep it lying around in my workshop and it works fine. But we're going to have a go at using similar techniques that we used in this one to construct a 2.4 GHz double biquad antenna. So a few things you're going to need are some needle nose pliers, and try and find some like this that have quite a large flat area that you can bend up against. And instead of measuring out each wavelength each time, get yourself some thick plastic like this and measure off once. This is a half wavelength at 62.5 millimeters, and I've got a quarter wavelength here, 31.25 millimeters. Now this biquad is going to be made so it sits in the middle of the 2.4 GHz spectrum, so around channel 6. You're also going to need some kind of spacer or support, because the actual element of this antenna, because it's a double biquad, is going to be a lot longer, and the thickness of the copper wire, it's not enough to hold it straight. So what I've done here, I've got two actual PCB supports or spacers, and I've put them together, and what I've done, I've roughly measured off 15 millimeters, because the element on this needs to be 15 millimeters away from the back reflector, and I've drilled a little hole in there, and I've measured them just a little bit short, because what's nice about these is you can just screw them out like that to get your 15 millimeter measurement absolutely spot on. So as well as drilling a hole through there to so you can feed the copper wire through, I've also put a groove in the top, so when the actual biquad comes back on itself, it sits in that groove and it stops them from touching. You can also use heat shrink to put in between your elements, and you know, make some spaces out of some wood doweling, something like that. So to start off with, then I'm just going to put a right angle bend in. I'm not going to bother measuring, I'm just going to make sure I leave myself enough copper wire on this end. So I'll put my first bend in there, so now I'm going to put a quarter wavelength bend in here, bending that way, and because the copper wire to build this element is so long, I've got 700 millimeters here, which is enough to build this antenna. You want a big area, because this is going to flip round as I'm turning, and I'm going to try and get it all on camera. There, my first bend in. So now we're going to actually put a half wavelength bend in here, but before we do, I'm going to put the first spacer in place. So I've got my first spacer in place, and I'm going to measure off a half wavelength now and actually bend this way. So we've got it looking like that. Now I'm going to do a quarter wavelength bending this way. So it's looking like that. And now I'm going to put my second spacer on this. So with the second spacer in place, I'm going to bend this way, so we start to get that bow tie effect. So it's looking like that. And as I said, because it's got a ridge in the top of this spacer, that top element there will just sit in there and it won't touch this bottom one. And like I say, you can use some heat shrink there to stop them from touching, Now I'll measure another half wavelength, and we're going to bend that way. And that's half of the element finished. So quarter wavelength. Bend like that, and another quarter wavelength here. So it's looking like that. So now we're going to measure another half wavelength. And we're going to bend down there, like so. Now we're going to put another spacer in here, and then quarter wavelength bent in on itself. Like that. And then a quarter wavelength to bring it back down, crossing over the element here. So once you've got it there, what I'm going to do is put this element underneath this one so it matches up with the other side, and we're going to feed our final spacer onto this wire. So final half wavelength. Then bend it in. So you've got that pattern there, and then a final quarter wavelength here, and then bending down that way. Just going to chop a bit of this excess off. And then a final bend. You see there? Should have something like that. Now what I'm going to do is I'm going to solder up these two wires here, and then I'm going to go in and get all the angles a little bit better and bend it out so it lays flat. So to make the housing for the biquad antenna, you want to get yourself some PVC pipe. This is 110mm diameter waste pipe, and you want to cut yourself a piece off 190mm long, no shorter than 190mm, otherwise you won't fit your element in, and you want to then cut it in half like this here. So once you've got your PVC pipe cut out like this, then you want to get some kind of material to make your back reflector from. Now we are going to stick some aluminium foil to this, so it doesn't have to be metal. I've got some thin plastic here. Now you can use thin perspex or some really thin plywood, something like that. And you want to cut out your sides to actually block these off here. So what you want to do is get whatever material you're going to use and just put your pipe on the edge like so, and then draw around in a semicircle to get a pattern, and then cut it out with a jigsaw or similar saw. Now I haven't been too accurate cutting these out. I've just made sure I've stayed on that side of the black line, because what we can do at the end is just epoxy it in like so, and then once it's dry we can get in with a sanding block and then sand it flat using this as a template, so you get a really nice clean job. Now the reason you want to cut your two semicircles out first is because you're going to use this along with the pipe to measure for your back reflector, because we want a little lip for these to sit onto, so we want the back reflector a little bit bigger than the PVC pipe. And the easiest way to do this is to use these two, put them on the end, and then line the pipe up on the edge, and then draw a line around and cut it out, and then you've got your back reflector. So what you want to do with the reflector is drill a 9mm hole through the centre so you can fit your BNC connector through. Just draw some lines from each corners, and where they cross, that's where your middle is. And you want to do this before you cover it in aluminium foil, because the aluminium foil can end up ripping and tearing as you're drilling a hole through this, so you're best off doing it first. So I sprayed the back reflector with some contact cement, and I've laid out a piece of kitchen towel here, and I'm going to lay down a piece of silver foil. Hopefully you're not getting too blinded by the lights, and then just place reflector over the top, and because you've got some kitchen foil down, just move it in a circular motion to make sure it makes contact with the glue, and you get rid of any air bubbles. You get a nice smooth finish. So then we'll just get a knife and go around the edges, cutting away the excess aluminium foil. So for this centre hole, if you just rub your finger around the edges so you get an outline, and then with your knife just make cuts going into the centre. So you want to get yourself a BNC connector like this one. They're pretty cheap, you can get them from lots of different places, and you want one of these because it has a little solder tag on the side, so we can solder on to that, because obviously we can't solder onto the aluminium foil. And I've made myself a little bracket. I've drilled a 9mm hole through there so I can fit the BNC connector through, and I've made this hole a little bit bigger so I can fit a tripod on, and made it out of one of these. I picked these up from the hardware store. I think a pack of 10 for £1. Weren't very expensive. So you want to tighten the nut on the BNC connector, but be really careful you don't tear the aluminium foil. And on this bracket that I've made, I've just put a little bit of contact cement on the back of that so it won't slide around too much and loosen this BNC connector. It'll stay in there really firm and won't move. Now I've got the little solder tag in place. Now try and keep your solder tag on a flat edge of this nut, because we're going to actually bend that up so we can solder our element to that. So as you can see there, I've actually bent that solder tag up vertically, and then just the end of it, just bent that at a right angle so we can still solder through this hole here. So what I've actually gone ahead and done, I've soldered in a short piece of wire into the top of the BNC connector, and I've tinned that up. Now just make sure it's you've got plenty of room to play with. Make it nice and long. You don't have to measure that off just yet. The two wires that we soldered together on the element here, I've gone ahead and trimmed the longer one off, and I made sure it's slightly shorter than the 15mm that we need for the gap between this element and back reflector. So I've made a 15mm little jig here out of some cardboard, and we're going to use that. We're going to lay the actual element on while we first solder onto this center connector here. But what we want to do, we want to tin up in the middle of this bend here, and we've already got some tin on here, so it'll make it much easier for us to solder up to. And so I don't burn my fingers, I've got a crocodile clip so I can hold it in place while I solder it, and I'm also slightly pushing down on this cardboard so I get it at exactly 15mm. So because I've tinned both these up, should go straight on. So that's the actual element finished now, and it's in place. I've epoxied these supports in place so they're held on there quite strong, and having the 4 supports is a lot better than just having 2 at the ends, because if you accidentally drop this antenna on the floor, then the force of being dropped can actually bend the actual element, the copper element. And just went around with my, again, little cardboard jig here, making sure that it was all 15mm away from this back reflector. So what we've got left to do now is to put the cover in place and sides, and again I'm going to epoxy those in place and let it dry, and then give it a sand and smooth it all off, and then some paint. So all it takes is 20 minutes work with a sanding block, just sanding on the edges using the actual plastic pipe part as a contour to work round, and you can get a nice smooth finish on all these areas where you've glued. And of course I've used the sandpaper and I've roughed up all the surfaces, and I'm just going to go in with some finer grit sandpaper now, just prior to painting it up. So this is the biquad antenna all finished with some paint, and I'm rather pleased with the way it's turned out. Put it on a little tripod there. Obviously if you make a single biquad antenna it'll be a lot shorter than this, so it won't be as long, but I'm really pleased with that. And just to compare, there's the 5 GHz double biquad antenna. So I think all that's left to do now is to hook this up to the alpha card and give it a test and see how powerful it is. So with the standard rubber duck antenna we're just getting just above 60. It's getting up to about 64 now. It keeps dropping, losing its signal and then reconnecting. So probably around 64. So what we'll do now, we'll disconnect the rubber duck antenna and we'll connect in the biquad, and we'll see what kind of performance we get. So there you go, it's jumped right up into the 90s. Really strong signal. It's a well worth building. So I enjoyed that. If you did, please give it a big thumbs up, and I'll catch you next time.